In this video, I'll show you how to solve the ALEKS problem called converting between decimal numbers and numbers written in scientific notation. I am going to show you how to convert this number 0.004747 into scientific notation, and I'm also going to do a few other types of examples as well, just so that you can see a little bit of the variety of numbers that you might see in this particular ALEKS problem. I've got the rules for converting into scientific notation written over here on the right-hand side. The first thing that we're going to do in a problem like this is find the first non-zero digit. So as we're reading the number from left to right, find the first number that is not a zero. In this case, here it is right there. And then the second thing that we're going to do is move the decimal point so that it is to the right of that digit. So I want to move my decimal point so that it's located right here to the right of my first non-zero digit. As I move it, I'm going to pay attention to whether I'm moving the decimal point to the left or the right, and I'm also going to pay attention to the number of spaces that it moves. Then I'm going to rewrite my number. Notice that I'm going to be dropping all of the zeros that are to the left of the first non-zero digit. So here's my first non-zero digit, and all of the zeros that are to the left of that, they're just going to get dropped. So this is going to be rewritten as 4.74. Skip on down here to step number 4. We'll talk about this in a second. We're going to multiply by 10 with an exponent that is positive if the decimal was moved to the left, which ours was not, it was moved to the right. Negative if the decimal was moved to the right. That indicates that we have a small number, something less than 1. And the magnitude of my exponent is based on the number of spaces that my decimal moved, 1, 2, 3. So this is going to be 4.74 times 10 to the minus 3. Let's try this next example. Find the first non-zero digit, reading from left to right. There's my first non-zero digit, it's the 4. My decimal point needs to be moved so that it is to the right of this first non-zero digit. Here's my decimal point, 1, 2, 3 spaces. And I'm paying attention to, number 1, I'm paying attention to how many spaces I moved, and I'm also paying attention to the fact that I'm moving my decimal point to the left. I'm going to rewrite the number, dropping any zeros to the left of the first non-zero digit. Well, there weren't any in this case, so there's none to drop. If no decimal point was originally shown, now that doesn't apply to us because a decimal point was originally written in the number, right? So we don't even need to finish reading this. Rewrite our number with the decimal point in its new location, 4.74700. Notice we're not dropping any zeros from this number because we did not meet any of the criteria for dropping a zero. Multiply by 10, positive exponent because the decimal moved to the left, the number of spaces that it moved, which is 3, that is the magnitude of my power of 10. Let's try this next example. Find the first non-zero digit, it's a 4. Locate our decimal point, it's right here. Now this number does not have a decimal point written down. When there isn't a decimal point written down, it is always at the very end of the number, to the right of the last digit in the number. Not the last non-zero digit, just the last digit. So we're going to take that decimal point and we are going to move it to the right of our first non-zero digit. I'm paying attention to the fact that I'm moving it to the left. And I'm also paying attention to 1, 2, 3, 4, 5 spaces moved. Now I'm going to rewrite the number. Drop any zeros to the left. Doesn't apply because I don't have any over there. So if no decimal point was originally shown, which is the case here, there was no decimal point originally written down in this number. If no decimal point was originally shown, drop all the zeros to the right of the last non-zero digit. The last non-zero digit is this 7, and I'm going to be dropping the zeros to the right. 4.747. Multiply by a power of 10. I have a positive exponent because I moved my decimal point to the left. This is indicating that this is a large number greater than 1. And I moved it 5 spaces, which is the magnitude of my exponent. Last but not least, take a look at this example. This one's kind of a trick. Find the first non-zero digit, it's a 4. Find the decimal point, move it to the right of the first non-zero digit. It's already there. There's nowhere to move it. Rewrite the number, drop zeros that are to the right hand or left hand side. We don't have any zeros at all, so there's nothing to drop. Multiply by a power of 10. Positive exponent if the decimal moved to the left, negative if it moved to the right. We didn't move it in either direction. The magnitude of my exponent is the number of spaces moved. I moved 0 spaces, which is my exponent. This is kind of a trick, and I do see this on ALEKS, so I just wanted to show you as an example of what to do if ALEKS gives you one like this.